Hello everyone, welcome to a new series I want to be working on. In the series, I want to make a simple game engine. In the series, I'll be using VS Code as my editor, MinGW as my compiler, and CMake as my build system. The game engine will be code-based, which means there won't necessarily be a engine UI like Unity or Godot, and the series will be mainly graphics focused. I'll be using Sokol as my graphics API. Some of you may have heard of Sokol. It is a cross-platform library for C and C++. It helps with making apps and access a graphics API like OpenGL. But it is also cross-platform, which means it can work on the web, Linux, Windows, and Mac. I chose Sokol because it is lightweight, and every module of the library is single header and is STP styled. Every part of Sokol is separated into separate files. So the Sokol app file is for window managing and all of that, and the graphics module is for the graphics API. As I said, it is cross-platform, and as of right now, it does not support Vulkan, but it is in development. And another reason I'm choosing to use is because I like it, and I think it's quite a nice library to use. So to start off the series, we'll be first start by downloading Sokol. So you can go to the Sokol GitHub. I'll try link in the description, and you can download it as a zip. After you've done that, you can extract it, and everything I'll be working on will be in this blank engine folder. So I'll open it, and the majority of way C++ projects are set out is that they have a include folder, and they have a source folder for your actual code. Include is for like all your third-party libraries and your include headers basically. So we can bring that in here, and we can rename our Sokol into just normal Sokol instead of Sokol master. Inside the Sokol folder, we can delete everything besides the license and utils. We won't be needing the rest. These are all the modules of Sokol, and in utils is also extra Sokol modules that we can use later on, which will be helpful when building our game engine. So I'll head back to VS Code, and again, as you can see, everything has been included. I'll start off by making a main.c++ file and a CMake list for building our project. It will start configuring everything. Just so you know, I'm using the CMake extension for VS Code, which helps me configure everything automatically. Start off by setting a minimum CMake version requirement. And then we can set our CMake C++ standard to 20, and we can set CMake C++ standard required on, and we'll do a variable called project name, and we just call it blank engine. After this, you want to set a new variable. So basically what this does is it globally recurses my src file and looks for any file that ends with .cpp or .atp and puts them into the list of source files. I do this way so I don't have to manually type in each file individually like this. If I have a main C++, I have to type main C++, and I have like another file, I have to manually type it out. So just by using the double stars in the global recurse, which will go through each subfolder, it adds it to the source files automatically for me. And then we can start by saying add executable, which will create our executable program. which will just be our project name, and it'll also include our source files. And we also want to set target properties, which are project name, and we want to set the property of properties output name to, let's just say, game. So this will be the exe name. So if I put like when I put game, it'll be game.exe when it builds. And when I do another set target property, so this property will tell CMake where to put our output files. So right now, there's a build folder that CMake automatically generates, but I wanted to put in a separate file called bin. So our exe file will end up in here instead of build, just to separate everything from the CMake files. And then we have a target include directories. So this target include directory basically tells CMake which directory, which folders our C++ code can access. So we'll give it access to our source folder and our include folder. So the way each Sokol module works is every module is a separate file, and each file will have a implementation. Implementations will only compile once, like a C++ file, but can be included in multiple C++ files. So I'll create another file called implementation.c++, which will do define Sokol implementation, which will tell MinGW that to compile Sokol in this file, which means any edits or changes we make in our main file will not cause Sokol to recompile every time. So in here we will do include Sokol app. And now in our main file we can do Sokol include. So in here we can start by saying Sokol has a default main that we can use, so we don't have to put our own int main. It's called sapp description Sokol main. So Sokol will hijack our main function and do the setup for us. Basically, all we have to do is define this function. We have to return a Sokol app description, and as you'll see throughout the series, everything in Sokol starts with an S and then the module acronym basically. So for a Sokol app description, it will be sapp description, and this will be a description for our app. Basically, it will just tell Sokol the configuration of our app. We need other functions called init, void frame, void event, and events will take in an sapp event, and we have another one called cleanup, which will, there we go. So for Sokol, for our description, we need to give it each a init callback, which will be our init function. Description.frame callback will be our frame function. Description.event callback will be event function, and description.cleanup will be our cleanup function. So basically, what it does is, when the program first inits, it'll run our init function. If every frame, it'll run the frame function, and every time an event occurs, like a keyboard or a mouse click happens, will be in the event function. And when we close the window, the cleanup function will be called. So it's a very clean and easy way of doing all of this. And next we can describe description our window title, so what the application window name is going to be. I'll just call it blank engine for now. Blank engine description.width, and then we can set our window width and height. So I'll make it 920 by 1080. with all of that, we can try compiling. So I'll cd into the bold folder, and I can simply type make -j, which will compile my C++ files basically, so I can run that. There. Oh wait, there's a error. Let's see, make file. Let's try that again. That might be a problem. Oh, so for CMake file, I just forgot to put the properties tag here. So we can try running it again. We try running it again. And, oh yeah, right, it errored, Sokol errored. For implementation, we also have to define which graphics API backend we're using. So there are many different backends we can use for, let's say, Mac OS will be using the Metal backend, and for web we'll be using web backend. But for Windows, I'll just be using the Sokol GL core, which is basically just OpenGL. We're telling Sokol that we're using the OpenGL backend. And it's successfully compiled. As you can see, our game.exe has been sent to our bin folder, and we're going to try running that. So I go bin/game.exe, and as you can see, our window is here. But there's a weird thing, I'm not sure why this occurs, but in Sokol, when your window scaling is set to something different than 100, the window doesn't necessarily get set to the size of what we set it in here. So if I run it again and I try to see the size of the window, it's, as you can see, it's not 1920 by 1080. It just tries to fit the whole screen. I'm not exactly sure what causes this bug. I've tried setting DPI scaling to false. That doesn't work, and I've tried setting it to true, which still doesn't fix it. So I think it's just a bug we have to work around. But I found a way to work around it, which is just to use the Windows header and detect the window scaling of cells and scale the pixels according to that. So we'll do a hashtag if define Win32, which is saying if we're compiling for Windows, we must run this code here, and we include the Windows here, Windows.h and define and if. And for here we go hashtag if def. Once again, we're compiling for Windows, and in this block we're just pasting this code. This code I found on Stack Overflow. Basically it detects the window scaling, the horizontal scaling, vertical scaling. I'll try to link it in the description. There's Stack Overflow post, and basically we'll take our description and we'll divide it by the scale, which will fix our window scaling, window size problem. So I'll try compiling that again. As you can see, our window is now 920 by 1080. The screen I'm currently using is 288 by 1918, so it doesn't fill up the whole screen because my screen is in 1920 by 1080. But as you can see, our window is now 1920 by 1080. Another thing you can see is that the window doesn't exactly look centered within our screen. We can also fix that by going into our init function, and doing more code. And if so this is the code I made a while back. So basically we'll get the window handle of our Sokol program by using subin, get the handle, so return the window handle, and basically it calculates the window position and the screen size and gets the screen center position of basically set the window position to be the center of our screen. So I can run that, and as you can see, our window is now centered on our screen. And yeah, we have set up Sokol, we have a window opening, and we can start putting code into our source folder and start creating an engine, right? But I actually don't like the way we're doing this, and let me show you why. So imagine this source folder was our game, right? And then we can have like separate folders, like a folder code for our game code and a separate folder for our engine. But I don't like it like this because let's say we want to make another game, right? If we want to make another game, we have to duplicate all of this And as you can see, we'll be duplicating our engine. So a different way I want to tackle this is actually to separate out the engine code separately into its own code base, so that for each game, we only have to link the engine while the engine's in a separate folder. So the way I'm going to do this is keep the source folder, but have a separate folder in here called projects, and this is where we will store our games and whatnot. So to do this, so now our source folder will not be our engine for our engine stuff, but our individual projects and games will be in the projects folder. And the way we're going to do this is by building the engine as a static library, and then in our in our games, we'll be linking the engine to it. So in the engine, we'll have a folder called app. So this is for the app module of engine, which will basically just handle windowing and everything else. And I have it called app. So I have a folder called app.hpp and another file called app.cpp. And then in here, also have another folder called third parties, which will be for libraries and everything else. And now we can move our Sokol library into this third party app here. And we can delete our include folder now. And in our app, we want it to be as a separate module, so it will have its own CMake list. List.txt. The way we will be writing out the CMake for our app module is, we'll start by saying set project name. Or instead of calling project, I guess we can call it module name, and we'll call it app. App. And we'll make it a project. Module name. Say version. Language. C and C++. And then we'll do the same thing as our original CMake, where we will just have it include everything, but just in this current directory without the source folder, because we no longer have a source folder in our app folder. That's why. And instead of add executable like our main CMake, it'll be add library instead, because we're building it as a library that other parts of that games can link to it. So project name static. So project name, and it'll be a static library. Static library means it'll be built into the exe rather than as a separate DLL file. And target sources, which is the these will be source files of the library. Source files. And we'll give it target include directories, just like our original C++ file. Name. But this time we'll make it public so that other CMake projects that link this module will also have access to its include directories. And we'll give it include to itself, so everything in its current folder and everything in the third parties folder. And there we go. We have now made it into a library. And I'll just move the implementation in here as well. So in our projects folder, we can now have another folder called demo. And in here we will have our main.cpp. Actually, I can just move this in here. We can replace it. So now main.cpp is in here. And in our demo, we have its own CMake list. CMake list.txt. And then we do something here. And here we can change the project name. And here, instead of making it as a library, we're making it as an exe, because now this is our actual game instead of a library. Executable. Give it source files. And so again, we give it properties. Properties. Here. And then include the directories. You can make it private because we don't want anything else to link to projects. Only modules can be linked. Private There's no third party. Well, we could have a third party folder, but for now we won't. And then one last one is the target link directories. This is where we link the modules of our engine. So for this, we'll just go project name and the module we're linking. So we'll be linking the app module, as you can see here. And in our main CMake list, we can comment all this out and we can individually add subdirectories. So it will be src/app and then add subdirectory projects /demo. So for app, we do paragraph once, so it can only be included in one translation unit. And I'll have it in a class. So I'll have it in a class called app. And then everything in that app will control how the program runs. So we can basically copy everything here. So we'll have a public and we'll have a private. So in the public, we'll do something similar to what Sokol does, where we give it a bunch of callback functions that it can be called. So have one called create callback. That's again as description. And another callback type void. Callback and coordinates. Callback. And void. They also include Sokol app. And just duplicate this. I have one called update callback. One called callback running frame. And then another one called cleanup. And one more zombie events callback. And it's a constant. Let's have events. And then we have another public function. This one will be actually callable. So return a ASAP description. That'll just be called create. And that'll take in a std string, the title of the window, and then it'll give us a width and a height. And it also takes in a width and a height for the size of the window. And then in the private section, we'll have separate functions called init, update, just frame, cleanup, and event. We also can accept it. Just copy all this. Oh, it doesn't right now. CMake. Oh yeah, the mistake was in our CMake list. I just forgot to. It should have been languages instead of language. There we go. Okay, and now in our app.cpp, we can include app.hpp, and we can start defining everything in here. So let's go this. And start defining it. And I have empty voids that do nothing for now. So I have a void called empty void that does nothing. Void empty ASAP description does nothing, and void empty ASAP event constant ASAP event ASAP description. And this is how we could set the defaults, just so that we don't have any undefined behaviors if these functions get called and we haven't set them yet. Empty event. And for this targeting functions, we have to make them equal to empty void. And now we can start defining the rest of all of these class functions. So for create, we'll do what we did in our main. Instead of here, we do width, height, and title. Instead of hard coding in, it would be taken in from the function. And also need to include windows.h. And then we'll start defining the rest of these other functions. And in our create function, we'll also call our create callback. Create callback, and I'll take in our asset description. And then in next, we'll copy this. So this was our censoring our Windows code. And in our frame function, we'll do update callback. And we'll also do a frame callback. The reason I separated into an update callback and a frame callback is sometimes we want to do something like first updates in a separate function rather than in the drawing function. Then clean up, callback. And events callback. And now in our main function, instead of including Sokol, we can just include app.hpp. And then we can remove everything else, except the baseline functions. And now instead of description, we can just go app dot init equals init function, app dot frame frame function, app dot event event function, and app dot cleanup function. And we'll have another function called update to hold our update callback. So app update callback update function, and then we just return. We just call app dot create because that will return our ASAP description that we need for our Sokol main. So I just call it blank engine 1920 by 1080, and we could try running that. Not one error. Oh wait, for CMake I just did double parentheses. Let me try again. Languages again, not language, languages. Oh yeah, it should not be app, it should be a different name, so we'll just call it demo for now. In our base project, we can have a project just called project, and just called blank engine. This is just to stop the CMake from giving us a warning of not having a project in the base CMake file. I just forgot to include string. Include string for our app.hpp. And for this, it should be a pointer, so I should make it a pointer. And for description or asset description, it doesn't take in a string, it takes in a C string, an array. And then for our callbacks, I just forgot a star at the beginning. It's not empty events, empty ASAP event. And it's not target link directories, my bad. It's target link libraries, because on a link library is not directories. My bad. And there we go. It both, as you can see, it both the app library separately, and then it both the game demo separately. And there's our exe. Try running that. And as you can see, we're back to where we started, but now our project is much more separated. Everything is much more modular, which makes it easier for us to add and remove things easier. So to conclude, we've separated our game code and our engine code into two separate folders, which makes it easier so that when we make new games, we can just link our engine rather than having to copy our engine code for every new game. And in this episode, all we've done so far is just create a window, but this is massively structure the way we'll be building our game engine by separating it into different modules that we can each link separately. That'll be the end of today's video. I'm sorry if everything feels a little bit disjointed. This is my first time doing something like this, so please be patient and I'll try to improve as the series goes on. Thank you for watching.